My name is William Sell, and for my CS90 cloud computing project, um, I built a financial article sentiment analysis classifier and then made that available via a Python RESTful API. So I'm going to go through some of the steps in building the sentiment classifier and then working with Python to make that into an API, a RESTful API. Some of my goals for this project were to train a sentiment classifier, basically with a corpus of documents that I hand classified, a large number of articles that I hand classified, positive and negative. Train that classifier so that when you would submit an article that you want sentiment run on, it'll return back to you a percentage score for positive and a percentage likelihood score for negative. So if it wasn't sure if it was positive or negative, it would return like a 0.5 positive, 0.5 negative score. And then to make this classifier available again by Python RESTful API. So why is this interesting? Well, I think this is interesting because if we can train an accurate classifier, then maybe we can use this to see if it has some sort of predictive power. Looking at articles over the last day or the last couple of hours and see if it has any prediction power into the future. Do looking at articles for a certain equity over the last day help us say anything about what the return is going to be in the next day, and just help us make trading decisions. So the training data, the corpus that I built, is 100 articles that I hand classified as positive and negative, 100 articles each. Those are articles spread out over the past year in tickers from the S&P 500. For each ticker that I pulled articles from, I took an equal number and classified as positive and negative. I did this to avoid making words, and we'll discuss that when we talk about how the classifier works. Words like Altria Group or Apple or Google be associated with positive or negative. And this process was admittedly imperfect, subjective, and very time consuming. To speak to the subjective part, I don't know necessarily that all the articles I would classify myself as positive or negative, that another person would say all of those, yes, are positive, all of those are negative. And time consuming, I think just building this training set probably took me about half of the entire time I spent on this project. So how this model works is when we're training it on the corpus, it's looking for words or bigrams, which are combinations of two words. And it's looking for these bigrams that are more commonly found in positive articles that we had classified versus negative articles, and vice versa. And then when you submit an article that you want classified, then it's going to look through this article and it's going to find these bigrams and say, well, how many bigrams do I have, and use that to determine if the model thinks that it's positive or negative. And then again, this is why we use the same number of positive and negative articles for tickers, so that the specific ticker or company name isn't associated with positive or negative. And I also attempted to use the same number of positive and negative articles for each news source. So if I pulled 2 negative articles from Bloomberg, I'd try and negate that with a couple positive articles from the same source. So the software that I used was Python-based, NLTK, the Natural Language Toolkit, and then there's another project as well, the NLTK Trainer, that you can use to train an NLTK model. Depending on exactly how you have Python installed and what modules you have and everything, I'm not going to go through the specific installation process. I think it's highly dependent on how your Python environment's set up. But I was able to do it fairly painlessly, within a handful of minutes to get both of these installed. So I suggest, going to each website and walking through their installation process. So in the second package, the NLTK trainer package that we download, it contains a script, train_classifier.py. And basically we can use this script along with some commands in our train corpus to build our classifier out of that corpus. And I'll go through some of the commands that you can use. So when training the classifier, I spent quite a bit of time experimenting with tons of different options, and I won't go over all of them, but basically, I had mentioned bigrams. You can use, combinations of n words. So, 3 grams, 4 grams, 5 grams are single words. You can use different amounts of the data as training and then as testing. There's really a lot you can do. I suggest going in and looking at the documentation on train classifier. But I was able to get a model with 93.3% accuracy, which I thought was pretty good. If you look at the command you run there, you can see that I used 0.7 or 70% of my data was used to train the model, and then the remaining 30 to test it on. And the rest, n-grams 2, that would be the bigrams that I had mentioned before, and the rest of it kind of has to deal with just output. And then if we omit the no pickle portion, it will actually save the model for us so that we can use it later in Python pickle format. And again, if you want to see the details of what all of these arguments mean, check out my write-up. I have a lot more in there. So here we can see the output from running that on our trading data. Again, we can see 93.3% accuracy, and then at the bottom there, we can see 10 of the most informative features. Other hand is 6.2 times more likely to be negative than positive. Return of 5.1 times more likely to be positive than negative. And it's really interesting. I suggest, if you're working with this, show more informative features and kind of get a feel for what your model is keying on. Okay, so now we have this trained classifier. We pickled it, we saved it, and we want to use it to classify new articles. So what we can do is we create a Python class, a new Python class, sentimentclassifier.py, and what we'll do here is we'll take the text for the article we want to classify, the new article, as input, and then we want this to output scores for positive and negative using our model. Here I'm going to just kind of quickly walk through how this class works. Here are imports, all the modules, and our pattern matching to split the words into an array. Then we, simply in Python declare the class, and we load that pickled classifier that we created before. Next, we can see that we split the words into an array. We're going to strip all non-alphanumeric characters, so everything that isn't a number or a letter, and we're going to convert everything to lowercase. This is what was done behind the scenes when we were training the model. So we're keeping our input data consistent with what we were training it on. And again, break it into n-grams. 2 grams is what we trained this model on, so 2 grams is what we should probably feed into it. And then we run the classifier on the document. Then we create a dictionary to hold the results. So we can see where it will return the probability positive and the probability negative, and we store that in a dictionary. And then that'll be returned. So now we can check it at the very end of this class with a test phrase. So we create an instance of the class, and then we input stock rises 5% today. On the other hand, falls 20% last week. Kind of tricky for a model, but it actually returns at the bottom. We can see 97% negative and about 2.6% positive. So that's pretty good. I'd say that's fairly accurate. Okay, well that's great. You know, we have a classifier built that's pretty accurate. We have a class where we can feed in a document and basically use that classifier to spit out positive and negative sentiment. But that's all local. Let's make this available via a RESTful API. So there's multiple options for Python. I found Flask to be the easiest to work with. And you can see that there's instructions, again, to install Flask at the link there. I won't go through that. So, to build a RESTful API, we in class covered how to do it in Java. I was interested, you know, to pursue this to see what the Python approach was. It actually, I thought it was fairly simple. You can do it with a single class, sentimentrest.py. So again, I'll just kind of run through my code very quickly with you here. First, you take care of the imports and see that we're importing the class that we just created, the sentiment classifier class. Next, define the class and the function. So this is going to be a put request. So really, you just declare a put function. And then this put function will be called whenever you make a put request. And the arguments are text. That's the request that we will make, which will be the document that we want classified. And then we'll feed that into sentiment classifier, which will then return the result. And then finally, you know, you simply tell the class what kind of input to expect, and you start the API when this class is run. That was pretty painless. You know, I had to play around with it for a little while before I got the results that I wanted. But there's some tutorials out there that you can walk through, and I think Flask is fairly painless to use. So let's put this all together. So we trained our sentiment classifier. We pickled it, we saved it. We built a Python class to use that saved classifier to feed an article into, and then we also have a RESTful API that we can submit a document to. It will put it into that classifier class, and then return a sentiment score, which then we will return to the user via the RESTful API. So first we can start the Python Flask REST class by running that Flask API class that we just created. And then we just test with a curl request. So if you notice, the text variable there is the exact same text that we tested it on a few slides ago. So then we get the output back in standard JSON format, as expected. You know, negative 97%, positive 2.6%, exactly the same thing. It's in a format that is pretty standardized, easy to work with. This was a pretty fun project. For next steps, I think personally I'm going to look at testing and seeing how accurate this data is, if it has any prediction power whatsoever. If you're interested in hearing anything else, any more of the details of anything I worked on here, there should be a little bit more in the write-up, and feel free to contact me personally by email or whatever. Thank you.